Alright, my dear friends, let's move to the next sum. This is about red, blue, and green beads mixed together. Oh, I put balls. Alright, fine. Red, 5 red, 3 blue, and 2 green balls are in a box mixed. So what is the probability that you will get 2 reds followed by a blue, or 2 reds and 1 blue? They're totally different. Like what we did in the earlier lesson, 2 heads and a tail, or head, tail. They're very different. And a minimum of 1 red in 3 pigs. Now I'm going to draw this probability tree, and if you can be with me, I truly appreciate that. What is the total number of balls in this box? 10. Great. Probability of getting a red, a blue, and a green. Alright, the probability of red is 5 out of 10. A blue is 3 out of 10. A green is 2 upon 10. What is the probability of getting a red? Alright, and then let's put no replacement. No replacement means you don't put it back. So you take it and that's it, no replacement. We don't want any replacement. When you take 1 red, okay, and then we put a green here. What's the probability? Take out 1 red. You got 4. Now how many balls are there? 4 plus 3 plus 2. 4 plus 3, 7. 7 plus 2, 9. So now you have 9 balls left. You just look at this path. 9. How many reds are there? 4 out of 9. How many blues? You've taken out only a red. Ignore this. You've not taken a blue. So you have 3 out of 9. How many green? 2 out of 9. When you add them up, 4 plus 3 plus 2. 4 plus 3 is 7. 7 plus 2 is 9. 9 upon 9 is 1 whole. Got it? Now at any one point, it should be 1 whole because it's either this or this or this, and it's definite to happen. You look at it here, 5 plus 3 plus 2, 10 upon 10 is 1 whole. When you put your hand to pick, you're going to pick a ball. It's either red, either green, or either blue. So there's a certainty in that event. And that's why it's 1 whole, 100%. Okay, if we go to the next part of it, you look at it here, you get a red, a blue, and a green. And if I taken out a blue, alright, I still got my 5 reds. So it's 5 out of 9. Remember, you've taken out the blue ball. This is just a disjointed event. Alright, this one set, this is a disjointed. Okay? If you have taken out a blue, and now how many blues do you have? 2. 2 out of 9, you've taken 1. If you have taken a blue, how many greens do you have? 2 out of 9. 2 plus 2, 4. 4 plus 5, you get 9. Now you look at the green. Green. Alright, you have a red, you have a blue, you have a green. Now you've taken 1 green out. How many reds do you have? Alright, the reds will be 5 out of 9. How many blues? 3 out of 9. You've taken 1 green out. You have 1 out of 9. 5 plus 3, 8 plus 1, 9 over 9. What is this called? Red, red. What is this? Red, blue. Red, green. Blue, red. Blue, blue. Blue, green. Green, red. Green, blue. Green, green. Now when I look at this event, a red, red, blue. I've got 3 pigs, my dear, and no replacement. So I said, I've taken a red, a red, a red, and from this red, I create my probability tree again, a red, a blue, and a green. Alright, this picture tells you 1,000 words, the whole probability. If you understand it, it's really, really powerful. You've taken a red, you've taken a red, 2 reds are out. So let's look at this. So how many reds are left from 5? Taken 2, you've got 3. But now from 9 balls, you've taken 2 balls out. You've got 8 left. So it is 3, 8. To get it, my dear. Alright, you've got 10 balls. And you've taken 2 reds out. There are 8 balls left. And from the 8, 3 are red. What's the chance of getting 3 out of 8 could be a red. As for the blue, there are 3 out of 8, because you've not taken the blue yet. As for the green, 2 out of 8. 2 out of 8. So what's the probability of getting a red, red, blue? Look at your probability tree, my dear. A red, red, blue. Yeah, it's here. Red, red, blue. This is a red, red, blue. How about this? A red, red, red. Okay? And what about that? A red, red, green. Aha! Red, red, green. So probability of getting a red followed by a red followed by a blue. They're all independent events but linking. You happen first, then you, and then you. So the probability of getting a red is 5/10. The second red, look at it, is 4/9. And then followed by a blue is 3/8. So that's what you get. 20 times 3, 60, 60 over 720. 9 times 8 is 72, 72 over 10. So the probability here is 60 out of 720. Alright, and then reduce it, please. You reduce it, you divide by 6, and you divide by 10, and then you reduce it. Now what's the probability of 2 red and 1 blue? You want 2 reds and 1 blue. It can be a red, red. Look at this here, red, blue, and look at the outcomes. You have a blue here, and then you have a red, and then you have a blue, and then you have a green. Look at this here again. What do we have? We have, let me take a purple, okay? Right, what do you have here again? You can have a red, you can have a blue, and you can have a green. Now beyond this, you can't get, can you get a red here? Yes, you can. So if you look at a red happening here, yes, but once you go here, here too you can get a red. So the chances of getting 2 reds and a blue will be red, red, blue, red, red. No, this is out. If you look at it, red, blue, red, yes, this you can. Here, red, green already, all cannot. So this all, how about here, red and green, cannot. You want a blue. So you look at it, here's a blue. If you look at it, look at your probability tree and decide. 2 reds and a blue. So probability of getting 2 reds and a blue, alright, whether it can be a blue, red, red, right? It can be a red, red, blue, plus a probability of a red, blue, red, a red, blue, red, plus the probability where else? You don't want a green, you don't want triple reds, blue, red, and then you can follow by a red, a blue, red, red, and where else? You can't go from here, blue, blue, red, nope, we want 3 reds, here's already green. So here's already green. When you go to green, and then you were not interested in green, here's blue, green, blue, red if you want here. So these are the possibilities, and you can see they are greater. Alright? So this chance will be 6 out of 720. This will be 6 out of 720, 6 out of 60, out of 720. Right? You look at it, you multiply them out, and you can work them out. You will get a 60 out of 720 times 3 times. You could reduce this, divide it by 6, you get 1 upon 12 times 3. You could see it is 1/4. The probability of getting 2 reds and 1 blue is better. Chances are better compared to this. If you look at this 60 out of 120, if I reduce it, you get 1 out of 12. Whereas in this case, you get 3 out of 12. Alright? 3 out of 12 is 1/4. Chances are a lot more better because they're not specifying the order of event. Here they are specifying red, red, blue. The first must be a red, not anything else. The second must be a red, and the third pick must be a blue. So your probability 3 will be red, red, blue. The probability of a red 5, 10 times 4, 9 times 3, 8. That's how you work it out. But if you want 2 reds and 1 blue, you're not fussy. Alright? So then it can be a red, red, blue, a red, blue, red, a blue, red, red. That's how you get it. Okay? So please take note of that. Now if you want minimum 1 red in 3 picks, 1 red in 3 picks, that means you just take 1 whole, you can get a red. This, if you look at it, you have to draw out the probability 3. Look at how you can get 1 red in 3 picks. Now, if I were to draw that out, you have a probability of 1 red in 3 picks. That means a minimum. Read the question carefully. You must have a red. So you must have a red in 3 picks, means 1 whole minus the probability of getting 3 reds. Look at this. This is a green, green, green. Out. Green, green, green. That's out. You want 1 red. So ideally, if you could do that probability 3 for me, it will be great. Let's look at that again and get it right. Let me clear the board for you so you can see it clearer. You want green, minimum 1 red. So if you look at it, all these have got 2 reds at least. This is all from the red stock. So this whole stock is within. Here you've got a red. It's all within. Here you look at this. We want to eliminate what it is because you've already got a red. So red, red, blue, green. Because they want a minimum. Here, you look what is out. So the probability that is out is 1 whole minus blue, blue. Okay, probability of a blue, blue, green, or a blue, blue, blue. Alright, minus a probability of a blue, blue, blue. What else? You have a probability of a blue, green. You have a blue, green. You can have a red will be in because minimum 1 red is a minus a probability of a blue, green, blue, and a probability of a blue, green, green. Okay, that's from this side. And here you get a green, red. This all in already, don't worry. Here you can have, look at it again, a green, blue, blue. Alright, the probability of a green, blue, blue minus the probability of a green, blue, green. And here you've already got a red. Sorry, you've got a green, green. Sorry about that. You look at green, green. So you can take a green, green. You have a red, it's already in, minimum 1 red. Because you want to eliminate from the 1. So you get a blue, green, green, blue. And a green, green, green. So you take all these properties, a green, green, green. And a probability of a green, green, blue. And that will give you a minimum of 1 red in 3 picks. Put in all your probability chances, work that out, and you'll get it. So that's the chance of getting a minimum of 1 red in 3 picks. Alright, if you look at it, 1 red. Here there is no reds at all. You're eliminating whatever in the probability tree that does not have a red. So do not fear, it's not very difficult. Just putting in and look at the probability tree will tell you all. Okay, now let's look at the next one. If 2 more green balls were added, 2 more green balls were added after the first pick. Alright, what's the probability of getting a green or a blue or a third, a red in the second pick? Okay, so when you took off 2 more green, if 2 more green balls were added, okay, what is the probability of getting a green? This is just a buzz session. When you took out, what's the probability of getting a green? Now there is a chance. If you look at your probability tree, all right, you've got a probability here. If you have taken out a red, draw another probability diagram. You've taken out the red. There were 10 balls. Now it's become 9. And when you put 2 greens more, from 9 plus 2, you get 11. Right? So you've got 11 balls. And the probability of a red appearing, they want a green. So from the 11, what's the probability of it being in the second pick being a green? It is 4. 2 plus 2 is 4 out of your 11. Because you've taken. And then if you look at the blue, if you look at this blue, okay, you've taken out a blue out and you add 2 greens. Okay, so we can draw a probability tree to see this interpretation. But I want to tell you that this question is a little bit ambiguous. Why? Because it's left to your interpretation. They did not tell you. I'm just telling you that, though I'm giving you this. There's a lot of ideas to look into it. I just want to open your concept of probability and ideas. That's why I'm giving you this question. Do not fear, because you see you're adding 2 more green balls after the first pick. So whether it's a red, whether it's a blue, whether it's a green, get your set of information, and there is a whole varied things to look into it. Okay? Hopefully, when we give exam questions, we wouldn't want to set questions like this for exam, because there are too many things to look into and it will take a lot of your time, because the question is not telling you what your first pick is. If you want the second pick, all right? So you got to look at that again from a different angle. I'll come back to it if I have the time with you to get back again, right? Now, I want you to stretch yourself, my dear. Probability, getting to know it, J-O-Y, joy, the understanding of chances. Give a deeper thought to all these things. Probability, chances.